section 5.3. This is example 6, and they go through with the Leibniz notation something a little different, or actually, yeah. Oh, now I'm confusing myself. I don't know if it's Leibniz or Newton. But at any rate, the dy dx notation. So they led up to that with just the idea that if I, have a function, and they're saying g prime of x, so again that it gets hard to think about the fact that you're swapping variables. So, ahead of that, I'm going to say, okay, remember g prime of y. Now, if g prime of y, so that's x as a function of y, I would write that as dx dy. Okay, but that we also know is our 1 over f prime g of y, like that. And so that would be our 1 over f prime of x, which is equal to then 1 over, and if I just use the other notation, we get dy dx. Okay, so what it's saying is if I'm at the corresponding points of the function and the inverse function, and I want those slopes, then they're just reciprocals. Okay, so we see that g prime of y times f prime of x is dx dy, and that's times dy dx. Now, these are not fractions in the sense each of these is a single notation. However, the notation does lend itself well to show us that, oh yeah, this is 1. But remember, I'm going to use this here, and so this is equal to 1 over dy dx times dy dx. And now we really do have fractions. I have 1 over a quantity times the quantity, and so I do know that's 1. And so, we see that taking those two derivatives at their respective corresponding points, that where they share an xy and a yx, if we look at their derivatives multiplied by each other, we get 1. They're multiplicative reciprocals. And so on to example 6. They're telling us in example 6 that f of x equals x squared. And notice they say for x greater than or equal to 0, so it really does have an inverse. And f inverse of x, now I'm going to toss in there g of x, is equal to the square root of x. And what they want us to do is look at these reciprocals, and we're going to take the point 2,4 here for f and the point 4,2 here for g or f inverse. And so here f prime of x is 2x, and so f prime of 2 is equal to 2 times 2, or 4. And over here we have g prime of x is 1/2 x to the negative 1/2. And g prime of 4 is 1/2 times 4 to the negative 1/2. Well, that's 1/2 times times, what the heck is it? 1/2, yeah. So 1/2 times 1/2, and so that's 1/4. And notice that f prime of 2 times g prime of 4 is equal to 4 times 1/4, which is 1. And they have you do it also for 3 and 9 and 9 and 3, and they also work out as reciprocals. Okay, so that is example 6.